Hello, this is Peter Homer from IBM. IBM Z is a critical component of a secure hybrid cloud strategy which aligns workloads with the most appropriate computing platform. Today's hybrid applications run on Z as well as cloud-based technology. To avoid skill silos in your development teams and be attractive to the next generation of developers, you want to establish a development infrastructure that can be used for both. So with IBM Wazi as a service and IBM Z development tools, you have the ability to use the same sets of multi-language and multi-platform tools on a developer desktop, on an on-premise cloud distribution, or in a secure virtual private cloud. When using these solution packages in the cloud, absolutely no installation or tools by the developers required, and all development activities can be done entirely in the browser. As a result, a new developer can join the development project and rapidly spin up a pre-configured development tool with a few mouse clicks and be productive working in that environment in an instance. So in this demo, we show you a typical Git-centric development workflow of implementing a enhancement request by our hybrid developer deb, who will perform all development steps in the IBM Cloud by just using a browser without the need of any system program involvement. So deb starts the day by logging into this Toolchains homepage on the IBM Cloud for the project that she's currently working on. There she sees an overview of the Git repositories used by the project, the status of the builds of the project and the pipelines, as well as a list of key development tools configured for her and her team to be used for development. From this dashboard, deb can open the Git repository with the source code and review issues that have been assigned to her. She can see that there's an issue assigned to her to add an average monthly order revenue to daily customer files in this report SAM application. So she reviews the description of the enhancement request, as well as provide some preliminary information about her understanding of the problem and how she intends to solve it. As she's going to know that she has to make code changes, from here she creates immediately a merge request that will create a development branch for her that she can use for all the code changes that she's making. So for a development environment, she needs a ZOS system in which she can build and test her application. So here she can use Wazi as a service, which is linked for this team directly from here. And here she can see all the virtual server instances that are available to the team that she can pick and choose from. Or she could quickly create a new instance using the create button. Within 5 minutes, she will be able to get her own ZOS system that runs in the cloud on real hardware and be available to her for development. But as she previously used this machine, DevTest6, she will just use this one, reusing this IP address, and use that for setting up her development environment. Going back to her dashboard, she can now go to the development workspace using IBM Wazi for dev spaces that's also being configured and set up for her here already in the dashboard. She can log into this environment, and the dashboard of Wazi for dev space will come up, and she can create her own development workspace for this particular branch in here. In this case, she decided to actually use already her existing environment and switch directly into that out of the dashboard. To make the setup in these browser-based development environments easy and repeatable, the team is maintaining a set of scripts together with the source code for various activities for setting up the development workspace, so building the application, running the application, so this becomes entirely repeatable and similar to working with other development environments. So that basically can provide the IP address of our VSI as well as the user credentials in the settings files, and then those convenient shortcuts can be used to execute those Ansible playbooks to set up the environment. Let's assume we already did script 1 through 3 and execute script number 4 now to run the application, so deb can see the actual output of the test data that is being processed by this application and use that as a baseline for development. This script performs a little test of the application and shows the output, so deb can use that now for comparing the before and after view when she's doing her development. The next thing she can do now is to actually dive into the source code and look at the application, bringing up in the COBOL editor in here, using the outline view to quickly navigate around and understand the source code. But also if she wants to try it out with the test data that we have, she can easily use now JCL that was uploaded by those automation scripts for running and debug the application on the remote VSI system. I right-click on here, submitting the job to start a debug session, and then using the launch here that's also been prepared through those scripts to connect to a parked session. After entering the password, and then being able to step through the application and look at data in variables and try to understand step by step how the application works and what the changes are that she needs to perform. After analyzing the application with the debugger, she has one more capability she can utilize. As she now understands that she has to make changes to copybooks and perhaps even add copybooks, she can do an impact analysis of the things that she needs to modify. For that, the Wazi for Dev Spaces workspace integrates with Wazi Analyze that allows you to run a static code scan, which is also prepared here through a shortcut of the code, and feed that into a web server that runs in the same container-based environment as the editor environment called Wazi Analyze. So in the web page, I can then search for assets such as my SAM1 program in here to do an impact analysis in terms of what are all the dependencies of SAM1 and how are these dependencies perhaps used by something else. So we can see that SAM1 is used by the unit test tsam1, but also calls another program SAM2, and we can look at the file references of SAM1 and can see that SAM1 includes 2 copybooks, and so a step has to make changes to the transaction records. She can also investigate now what else is using the tranrec copybooks, and she can see that it's been utilized by SAM2 and another application SAM1 lib that also would have to be updated in case this copybook would have to be changed. So after the analysis, Deb has now enough information to make her code changes, and the first thing she will do is now going from the main branch and switching to that branch that was created via the merge request on GitLab that's now available here in the environment. And now she can start coding utilizing the COBOL editor provided by this environment. Jumping now forward in time, we can now see that Deb made various code changes. We can see those change bar here on the left-hand side that indicate all the changes that we did for this particular update. The Git integration allows me to even review these side by side. I can see exactly the code that was added and deleted with color coding, so I can easily review what changes I made. I even updated our test data with a new transaction type entry here to test the new code as well. And so what I can do now in here, I can directly build and run the application directly out of the editor as if it would be any other programming language. So I can do a right click in here, run IBM user build, so it will analyze the program, find all the include files, and upload them together with a program, and then build the program on my ZOS VSI. So you can see the SAM1 program was built and the 3 include files. We added a third include file in here for this change as well, was uploaded, and the build executed. I can then even go in and run my run program again that I ran earlier to make sure the program still runs and the outputs that I'm expecting are still okay, utilizing now this new test data or updated test data that gets uploaded to the machine for execution. This script completes, and now can see the updated output. So a new crunch transaction type was being processed in here, and Deb can see now that everything looks correct, and she thinks the work is done. So she can now basically create a commit, edit crunch transaction, and then push this commit to the GitLab repo that she was cloning from originally. So those commits that we were pushing will end up directly, as you can see here, in the match request that we created earlier. And now this will then trigger in our tool pipeline that we saw here in our dashboard at the beginning, a new build that will build now the application with these changes. The pipeline can succeed or fail, and Deb can at any time Also drill into the different steps of the pipeline and review all the logs in here. So here, for example, are all the build steps that get executed, the application files that get built, and unit tests and code coverage results being collected. In addition to reviewing individual build results, Deb also has in her dashboard a link to the DevOps Insight application that collects build results and gives me an overview of all the builds running, as well as quality dashboards where I can drill into the latest information about code coverage testing, but also other static scans that are performed on the application, look at specific details of the current state of the application, look at code coverage reports, see where they are in terms of the distribution of the coverage, and so on. So now that Deb reviewed her review, she can be more confident that this is a working merge request, and she can go into the merge request UI now to ask for reviews by adding reviewers and so on. Then the final step would be to merge this into the main branch after the review, which would then end up in the CI pipeline that builds the entire application out of the main branch. This concludes our demonstration of how a development team can develop COBOL application end-to-end in an all cloud-based tool environment. All the tools that you saw here are running in the browser. Nothing was installed on my laptop. I was able to do an entire end-to-end workflow just using a browser and cloud-based development tools. If you want to learn more about our DevOps for IBM Z story and these types of development scenarios, then please read Chapter 5 of our new IBM Red Book Hybrid Cloud with IBM Z.